This is the next lesson in our topic on similarities. This is Learning Target 2. And in Learning Target 2, we're going to write similarity statements and find scale factors when given similar shapes. So the key important parts of this learning target are similarity statements and finding scale factors. So what are similar shapes? As you see right here, these two triangles have angle measurements of 30, 110, and 40. Both of them do. They do not have the same exact size sides. The side lengths are different, but the angle lengths are the same. This is very much a part of what similarity really is. For two shapes to be similar, all corresponding angles are congruent. What this means, it means that like congruent triangles, which are exact copies of each other, these angles are also congruent. So our 30 matches our 30. Our 40 is congruent to our 40. And our 110 is congruent to our 110. But on top of that, all corresponding sides are proportional. This means that they all have the same scale factor. So if I was looking at what it takes to turn an 8 into a 24, 24 divided by 8 is equal to 3. 18 divided by 6 is also 3. And 12 divided by 4 is also 3. So the scale factor for all the corresponding sides is equal to 3. Just like congruent shapes, we can write similarity statements just in the same way that we wrote congruent statements. Now I want you to go ahead and put APE on your small triangle and DOG on your big triangle. So this is what a similarity statement looks like. In between the two names of the triangles is the symbol for similar. And exactly how you saw in your congruent statements, we do pay close attention to the way that we order these two names. Since both A and D both have a 30 degrees angle, those are going to be the first letters in our name. The P and the D both have 40 degree angles, so they both come second. And the E and the G, they both have 110 angles, so they come third. Just make sure that you're putting a little squiggly for similar and not a squiggly with an equal sign. That would mean congruent. On the next example, I want to use the scale factor to create the new sides of a triangle that is similar to the larger triangle. We're given a scale factor of 2/3. All I need to do is take that and multiply it to each of the sides of the larger triangle. So 9 times 2/3, and 3 times 2/3. 9 times 2 is 18, divided by 3 is 6. 3 times 2 is 6, divided by 3 is 2. So my new sides of my new triangle are 6 and 2. In this example, we're not given a picture, so we'll probably want to draw one. One side of a dilated square is 24 inches. If the scale factor is 2.25, then what is the side of the original? So I'm going to create two squares. Since my scale factor is 2.5, that scale factor is bigger than 1. So that means that we created a larger square than the original. Now one side of the dilated square is 24. Usually when we dilate and use a scale factor, we multiply by that scale factor. But if we already know what the 24 is from multiplying, we would have to divide to go backwards. So let's take our 24 and let's divide it by 2.25. I get approximately 10.7. So my original square was approximately 10.7 inches. What's the scale factor in this dilation? So we learned how to make these dilations. We learned how to use centers of dilation in order to create the bigger shape. It's already been done for us here. We weren't told what the scale factor is, so I really don't know how much bigger these two shapes are from each other. So let's start by creating those lines that would have made the scale factor. So there's one of those lines. Now what I'm going to do is I'm going to use a ruler and I'm going to measure out how long the distance is from the point to the small triangle and from the point to the big triangle. So let's spin this guy around. Remember, when you do this, you need to make sure you put 0 on the center of dilation. What I see in my ruler is from the center of dilation to the first triangle, the length is about 8 centimeters. And the length all the way to the image is 16 centimeters. What this means is this shape is twice as big because 16 divided by 8 is equal to 2. So my scale factor is 2. So that covers our examples. We talked about how to write a similarity statement. We also talked about how to come up with scale factors and use scale factors to figure out the size of shapes. Don't forget to hit the submit button once you're done watching the video and taking notes.